10.5 covers multiplying monomials. A monomial is a number, so such as 23, 0.5, a variable such as x or y, or a product of a number and variable such as 14xy. That's a product. Product means to multiply. So those are all examples of monomials. When you multiply powers of monomials, when they have the same base, okay, they have to have the same base number. You would add their exponents. An example, you have 2 to the 4th times 2 to the 3rd. There's times happening right there. Here's your same base number. When you have the same base number, you add your exponent, so 2 to the 7th power. If you think about it, this is 4 2's, this is 3 2's. 4 2's plus 3 2's would give us 7 2's. Look at the next problem. Same base, A, same base number. When you multiply, you add the exponent. So this would be the expression there for that algebraic example. Example 1, multiplying powers. Find 7 to the 6th times 7 to the 2nd. Express using exponents. So we look at this, they have the same base number. When they have the same base number and it is multiplying, you would add your exponents. So we'd have 7 and we'd have 6 plus 2. When they have the same base and it's multiplying, add exponents. So this answer would be 7 to the 8th power. Example 2, you have two monomials that you're multiplying together here. You have 7x squared is one monomial. Now you're multiplying it by 11x to the 4th power. You're going to express using exponents again. Remember, you have to have the same base. 7 and 11 are not the same base, so you would not add the exponents. So you would simply go ahead and carry out that operation. That operation is multiplying, so we really have 7 times 11. I'm going to multiply those two whole numbers. You're also multiplying x squared and x to the 4th power. Those have the same base. When you have the same base, you add the exponents. So we have x to the 2nd plus 4. Because this has 2 x's, this has 4 x's, and we'll figure out that in the end, it's really x to the 6th, and we have 7 times 11 gives us 77. So the answer here, 77x to the 6th. 3. The loudness of a lawnmower is 9 times as intense as the loudness of a pin dropping. The sound of a rock concert is 10 to the 4th times as intense as the loudness of a lawnmower. How many times as intense is the loudness of the rock concert compared to the loudness of a pin dropping? Looking at this problem, we need to figure out how many more times intense is the rock concert compared to the pin dropping. Well, we know that 9 to the 10th times is a lawnmower. The lawnmower is 9 or 10 to the 9th times as intense as a pin dropping. The sound of a rock concert is 10 to the 4th times louder than a lawnmower. So here's 10 to the 9th. That would be the lawnmower in comparison to the pin. Times 10 to the 4th. 10 to the 4th is, in comparison, the rock concert is 10 to the 4th times louder than the lawnmower. So when we multiply these out, they have the same base. When they have the same base and you're multiplying, you add exponents. So 9 plus 4. So we figure out that the rock concert is 10 to the 13th power louder than a pin drop. Example 4, multiplying negative powers. I'm going to show you a couple different methods that you can use. They're going to multiply 4 to the negative 8th times 4 to the 3rd. We need to express using a positive exponent. Here's the first method. The first method looks and says, all right, these have the same base number. When they have the same base number and you multiply, you add the exponent. So when you do that, we have 4 to the negative 5th would be our answer. Now, the way to get rid of a negative exponent is to make things a fraction. So I'm going to go ahead and make this a fraction. You move whatever has the negative exponent. In this case, 4 to the negative 5th has a negative exponent. You're going to move it. It's on the top. When you move it to the bottom, it gets rid of the negative exponent. So I'm going to move it to the bottom. which would now say 1 times 4 to the 5th power, because it gets rid of the negative exponent. And then on top, what's left on top? Well, 1. 1 is left on top. Really, if you think about it, your 1's would cancel, right? Really, or if you think about it, 1 times this number is that number. So basically what you have is 4 to the 5th on the bottom over 1. And that would be expressed using a positive exponent. Second method that you can use, the second method is to go ahead and get rid of the negative exponent right away. Here's the negative exponent. That is in your numerator. So we have negative 8, make it a fraction, right? And we have times 4 to the 3rd. We can make that a fraction. Move the negative exponent. Well, here's my negative exponent. That is in the numerator, so I move it to the denominator. When I do that, it gets rid of the negative exponent, so I now have 1 on top. On the bottom, I have 4 to the 8th power times 4 to the 3rd power over 1. And this is really essentially saying, well, 1 times 4 threes. There are 4 threes on top. You have 4 eights times, or sorry, 8 fours times 1. So I have 4, 5, 6, 7, 8 fours on the bottom. Now, when you do this, you simplify. Well, cancel them out, cancel them out, cancel them out. So on the top there is a 1. On the bottom there is 1, 2, 3, 4, 5. 5 fours, which would be 4 to the 5th power. And you can look back at the previous example, and that's what you ended up with as well. So 2 ways you can solve. Example 4, you have 8 to the 7th times 8 to the negative 4th expressed using exponents. So again, same base, multiplying, add exponents. We have 7 plus a negative 4 is the exponent. When you do that, you have 8 to the 3rd power. Combining 10, 6. 10, 6 is on dividing monomials. Key concept shows, again, when you have the same base, you subtract exponents. Example, here it is. This division is happening. Same base, 7 and 3. Same base, dividing, subtract exponents. Simple concept, just the opposite of multiplying. So again, here we'll express using exponents. We see we have the same base number. So I'm going to put the base number down. When it's dividing, you subtract your exponent, so it is the numerator, subtract denominator. So we have 12, subtract 2, we get 6 to the 10th. Second example is an algebraic example here. We have A, again, same base. So I'm going to write the base number down. And then we have division, so we'll subtract the exponents. And we have numerator subtract denominator, so 14 take away 8, and we have a to the 6th power. Dividing using negative exponents, you'll have to simplify 8 to the negative 5th divided by 8 to the 2nd. And again, here you'll have to express with a positive exponent. So first thing, start off, same base, division. Well, here's that base number. When you divide and they have the same base, you subtract exponents. Numerator, subtract denominator. Here's the numerator. Numerator is negative 5. Subtract. Denominator is 2. Gives us 8 to the negative 7th. That is not our answer because it says up here that we need to write it as a positive. Well, how do we write it as a positive? Make it a fraction. Move whatever has the negative exponent. 8 has the negative exponent. We move it to the bottom. When you move it to the bottom, it now becomes a positive exponent, and we'd have 1 over 8 to the 7th power would be our answer. Simplify again here. 8y to the 3rd divided by 16y to the 2nd. Express using positive exponents. Well, right here, 8 and 16, they are not the same base, so you cannot subtract them. When you did not have the same base last time for multiplication, you went ahead and multiplied the numbers. So here, we're going to go ahead and divide them. So this is really 8 over 16. 8 over 16 would reduce to 1/2. So basically you have 1 over 2 and we still have y to the third, and we still have y to the ninth. So figure out what has the same base. I'm going to go ahead and say 1/2 here. What has the same base are your y's. So I'm going to say y, and again it is numerator minus denominator. So 3 take away 9. We come up with 1/2 y to the -6th, right? So if you think about it, y to the -6th is still on the top part. So I'm going to go ahead and write it up here. 1 over y to the -6th, and on the bottom you have 2. Still not finished because you have a negative exponent. What has the negative exponent? Y has the negative exponent. So y is what moves. So I have 1 over 2 y to the 6th. This will conclude lesson 10.5 and 10.6, multiplying and dividing monomials.